Section 1.5 covers the union, intersection, and difference of sets. So let's say I have 3 sets that I'm starting with, and we want to think of ways we can form new sets out of these. So by combining these sets in different ways, we can get these new sets. So there's 3 ways we're going to talk about doing that in this section, and those are the union, the intersection, and the difference. So let's define the union first. So the union of 2 sets, we're going to write this as A union B. And it's going to be defined to be the set of all elements X such that X is in A or X is in B. And in math, or always means or both. So it's anything that's either in A or in B. So I'm going to combine them all together. So I can think of this in our specific example, A union B. I'm going to first have all of the stuff in A, 1, 2, and 3. And then I'm going to throw in the stuff that's in B. So I already have the 3 and the 2 in my set. So I just have to add in that 4. So that's going to be the union. Now when you're typing these, either in CampusWire or in LaTeX, to get this union symbol, I'll just kind of throw that in there, it's actually \cup. It's kind of a weird one, but it's called a cup. All right, next for intersection, A intersect B is going to be the set of all X such that X is in A and X is in B. I didn't do the best job at drawing this intersect symbol, so let's go ahead and try that again. It should be just like that. I shouldn't have that extra tail. So here it needs to be in both sets. So in my example, A intersect B, I look at the stuff that's in that overlap. So 2 was in both of my sets, so I'm going to list that. And 3 was also in both of my sets, so I'm going to list that. So the union is all of the stuff together, and the intersection is just the stuff in that overlap. The tech command for this guy is cap. So the cap sort of caps something off. The cup is going to be the one that faces up. So just a little memory technique here for this intersection and union. The union one kind of looks like the letter U. So that can help us to remember that that's the union. That's the way I remember it. And then the intersect one, I always kind of think of it as like a capital A with the line missing. And that reminds me of the word and, because it has to be in both of them. So really you want to think about this one as both. Well, both together, the overlap. It's kind of hard. I could imagine how you could think about both or and as the union instead. So I'll include the word overlap here. Okay, and now for the difference. The difference of 2 sets, A minus B, is going to be the set of elements X such that X is in A and X is not in B. So you start with the stuff that's in A. Well, I have 1, 2, and 3, but then I'm going to get rid of anything that's in B. So if I sort of think about building this up, I have my 1, 2, and 3. And then I get rid of the 2 and the 3 because those are in B. I don't need to worry about getting rid of the 4 because that wasn't in there to begin with. So my A minus B is just 1. Let's look at a few more examples here. So I encourage you to try these on your own. And when you're ready to go ahead and replay the video and see what you get. So for A union B, I'm looking at the things that are in A. So that gives me 2, 3, and 4. And also include the stuff that's in B. So I'll throw a 1 in there from B. And also the 5. I already have the 3, so I don't need that. So my A union B was 1, 2, 3, 4, 5. For the intersection, I'm just looking at the overlap there. So I notice that 3 is in both of my sets. So I get that 3 is that overlap. For A minus B, I'm going to take the stuff in A, 2, 3, and 4, but then I get rid of anything that was in B. So 3 was in B, so I get rid of it. So I'm just left with 2 and 4. Now for B minus A, I want to think about starting with that stuff that was in B. So I start with 1, 3, and 5. I again get rid of anything that was in both, so I'm going to get rid of that 3. So then I'm just left with 1 and 5. So we can notice that these are different from each other, which we expect, right? Generally A minus B and B minus A are not equal, or if they were just numbers, they are usually equal to the negative. But in this case, they're just completely different sets. Okay, do a bit more over here. So if I look at B union C, I'm going to get 1, 2 from C, 3 from B, 4 from C, 5 from C. Again, you can write these in any order. I like to just put them in numerical order so it's easier to recognize. Now let's do some more complicated ones. First, I'm going to start with A intersect B here, because that's in parentheses. We already found that. We know that's 3. Oops. And then I'm going to union that with my C, 2 and 4. So I get 2, 3, and 4. Now I'm going to do a similar thing. First, I'm going to do B union C. So B union C is 1, 2, 3, 4, 5. And I'm going to intersect that with A, which is 2, 3, 4. So I'm looking for the things that are both in A, 2, 3, and 4, and B union C, 2, 3, and 4. So we get both of those happen to be 2, 3, 4. Now, generally we have to be careful because it turns out that there are going to be some cases where the parenthesis order matters. So we have to be careful with these parentheses. So I encourage you to see if you can come up with an example where you get different things for these two sets. Okay, moving along, let's do one more. We want to do the union of A minus B, which we already found to be 2, 4, and B minus A, which we found to be 1, 5. So if I union those, I get 1, 2, 4, 5. Make sure you go through these examples and check that they make sense. See if you can do similar ones on your own. Here's a question I want you to think about that we'll discuss in class. So if the magnitude of A is 3 and the magnitude of B is 4, what are the possible sizes of the union of A and B, the intersection of A and B, and then the differences of A and B in each of the two orders? So think of all possible numbers you could get for those sizes. When we have sets that aren't just listing out the elements, but are instead given to us as intervals, we can still take those intersections and unions. So let's think about what that's going to look like. Here, I have the interval, closed interval from 3 to 4, and then I'm unioning that with the closed interval from 1 to 5. Because it's union, I'm taking things that are in either one of the sets or the other set. So all of the numbers from 1 to 5 are going to be in one of the sets. So we get that this union is actually just equal to the second one. So this gives us kind of a question that you can maybe think about. When is a set union another set just equal to that original set? Okay, next we have 2, 4, union 3, 8. So again, if I want to sort of think about this, I'm going to have 2, let's call this 8, and then we'll have our 3 and our 4. So the first interval I have is the interval from 2 to 4. The second interval I have is from 3 to 8, not including those endpoints. And so when I union those together, I want to think about any number that's in either of them. So I'm going to get everything starting at 2 And then I'll jump up. I've got 4 in there. And I'm going to go all the way up to 8, but I'm not going to include 8. So the interval that's closed on one side and open on the other will be that union. All right, let's do one more. I want to look at doing 0, 3, 0, 3, minus 1, 2. So I'm going to take this interval from 0 to 3, and I'm going to get rid of all of the points from 1 to 2. So I'm still going to have these points starting at 0 all the way up to 1. I did get rid of that number 1, so now I have an open interval there. And then I'm going to start again here at 2, but not including it, and go up to 3. And I include that 3. And I can write that as the union of those two intervals. So that's going to be my difference there. Let's end with a few discussion questions. So the first one is I want you to sketch these two sets. One is the subset of R2 where x squared plus y squared is less than or equal to 1. And the other is a subset of R2 where x is greater than or equal to 0. So draw them on separate diagrams and then think about their union, their intersection, and their difference in the two different orders. So I encourage you to draw this out before class on a nice piece of paper, and then you can just take a picture with your phone or something, and then you can put that picture into the Jamboard for a class discussion. The other discussion question I want you to think about is the following. If you take R cross Z and intersect it with Z cross R, do you get Z cross Z? And similarly, if you take R cross Z and union it with Z cross R, do you get R cross R? So think about whether or not those are true, and we'll discuss them in class.